Exactly. So let's put this into presentation mode and let's start really quickly. All right. Are we ready to go? Sounds good. Okay, cool. Right. So today we're going to speak about why Backstage is not your platform. And I like, as a disclaimer, I have nothing against Backstage. I know many of the people that have built Backstage. I love them. I hold them, dearly. I love them dearly. This is not about Backstage. The only thing that I think I want to, say, like the title says it, Backstage is not your platform. You can use Backstage, but in the right horse for the right cause. You need to make sure that you do not abuse these things and that you use them for the reason they were made for. And so today I want to give you a quick introduction to Backstage, and I want to give you a couple of recommendations. Maybe if we have time, I can give you a quick demo on like a platform that was set up using Backstage in combination with Backstage, using Backstage as a front end to the platform, which is what it is. Yeah. All right. So with that, let's start. As we said, we are going to have Q&A. You're going to be able to ask questions. And if there are any questions that make sense in between, just write them into the chat and I'll try to monitor this. We will try to monitor this. Yeah. Here is actually a true picture of the Backstage boys at a book signing at KubeCon in Paris. Fantastic. KubeCon, by the way, for those of you who were there. We had a nice party. I enjoyed that a lot. And you can see here Spotify, Sean, ThoughtWorks, Todd, Agile, Amy, Exec, Eddie, and DevOps, Dan. The crew together to actually celebrate, I don't know how many years of Backstage. Backstage was originally developed by Spotify, obviously, and ThoughtWorks. Spotify has given the world a lot of things, a lot of good things, and then things for engineers. They've given us the squad model, and I'm sometimes not sure whether they're doing this for HR reasons or why exactly, but they're doing it. So we are dealing with it. And so here they've actually teamed up with ThoughtWorks and to actually deliver something for other people. Like they have been using Backstage internally, that is correct. I'm always a little careful if it comes to large enterprises that are saying, hey, we've built this tool for ourselves and now we're making it available to the world. There is a certain reason that nobody else is doing this. What do I mean by that? I mean, there's the famous case of Kubernetes, but by the way, Google isn't using Kubernetes internally. They have their own version of things, and they've rebuilt Kubernetes from scratch to make it suitable for the 80% of organizations out there. There is the famous case of, or like the most famous case that I'm aware of, 2017, I think. Jason Warner, the then VP of engineering at Heroku, joins GitHub as their CTO and says, oh my God, that's a lot of mess here. Let's clean up. Let's build an internal Heroku based on Amazon Web Services. They built their own Heroku. It works fantastic. That's what I call the first real internal developer platform. Everybody loves it. And Jason looks at this and goes, this is interesting. A lot of other people could use this as well. And then Jason does one thing, and that is he builds GitHub Actions, and he doesn't do another thing, and that is make this thing that he built for GitHub internally available to the rest of the world. Why did Jason not do that? Because Jason is a very experienced developer tool engineer and manager and knows that something that has been built for one organization does very rarely apply to any other organization. That is, I think, a learning that Spotify could have also included. There is another famous example here, Spinnaker. I don't know who of you are still suffering from Spinnaker. That was a Netflix idea where they thought, hey, we can use the tools that we've built internally and give that to the rest of the organization. Yeah, so you can already sense I'm not a huge fan of people just shoving stuff they're building internally down other people's throat. But we are faced now with a situation where Backstage is really popular. So we'll have a look at this. Now, another scary example here. Like this will be full of scary examples. And I think it makes sense that this is full of scary examples, because if I think about a single reason why we will hit the trough of disillusionment in platform engineering, then it's because of this here. It's because of misinterpreted Backstage setup. So that's why I'm warning so much, so that you take this really serious. This here is my favorite example of somebody not really understanding that the job of platform engineering is not done if you put a user interface on top of Jenkins. That's not the job. So this here, and I always use that example, and I encourage you to just don't take my word for it. Go to YouTube and watch these videos yourself. The first one that I would like you to watch is Platform Con 22. Brian Leatham, at this point, the guy in charge of platforming at Netflix, gets an absurd amount of money, and Netflix says, go, build me a great platform. And they're going ahead in 22. They're completely euphoric. Everything is great. Let's build this fantastic platform. And they want to unify the Netflix engineering experience with a federated platform console. Sounds amazing, Brian. Great. Brian goes ahead, large team, builds this thing. 1 year later, 12 months and millions spent. Platform Con 23 is less euphoric. We are hearing sentences like, the view and assess experience provides value, but on its own is not yet compelling enough to pull users in away from existing habits and routines. Really interesting sentence. The view and assess experience provides value, but on its own is not yet compelling enough to pull users in away from existing habits and routines. And there is a lot wrong with that sentence. Platform engineering is not about pulling users in and away from existing habits and routines. Platform engineering is not about view and assess capabilities. It's also about, but it's not solely about. Now, 2024, there was no talk at Platform Con because Brian was no longer at Netflix and that team didn't really work out. And so here we are. And Netflix is, currently resetting and thinking about how do we get that under control. And I love this example because you've been at so many webinars and so many conferences where they used Netflix and Airbnb and all of those heroes as the perfect example for how the world should be. And all of you thought, hey, amazing, I want to be like Netflix. Now, good news, you don't want to be like Netflix. You want to make things different. And so let's see how you can do things differently. Yeah, so now it starts in the video, which is exactly what I didn't want. Okay, so let's continue. Here, why can this be dangerous? What can you do wrong? Now, I want to introduce you to a fun game called Infrastructure Tetris. It's the game of, it works as follows. You take a Backstage setup and you build like a little button called, for scaffolding that people can click. And then there'll be a bucket. And in that bucket, you will just, gather all of the fun cloud resources that were created by clicking on that button. And so Infrastructure Tetris is the art of having application developers click on that button and trying to hit the niche in that bucket. Makes developers really happy because it feels like they're creating something. Makes executives super happy because it looks great. Makes infrastructure teams super unhappy because they have to maintain this. And makes the entire organization super unhappy because 12 months from now, you'll realize that you could have just used GitHub scaffold mechanisms and you don't really win anything. And this is a really, 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 really important message here that you need to internalize. Platform engineering is a multiplayer game. You cannot optimize the experience on one group at the expense of the other group. I mean, you can do that. That goes well for 2-3 demos to your executives. It will not last because nobody's going to use this. Now, if you look at a pain to impact mapping on platform engineering, then we all usually talk about the developers. You talk about missing self-service and waiting times and cognitive load, and we're slow. But there is another side to that medal, and that is the infrastructure team. And the infrastructure team also has problems. They have a low degree of standardization, and they have ticket ops, and they have insecure configurations, and they have manual reviews. They have costs that are spiraling. And if you go in and you optimize one group, but you don't think about the other group, you don't win anything. So in my world, you need to focus on two things. On the one hand, automation. You need to make sure that you automate the setup, and you need to standardize. You need to think about, how do I standardize? How do I build a platform that takes ownership, that really structures things, that manages the life cycle of a resource, for instance, over the entire period? Now, my first hint to avoid this one-sided view is in how you compose your platform engineering team, or who has a seat at the table. And my recommendation is, make sure you don't only have infrastructure people. Make sure you do not only have DevX people. A mix is really important. So I'm thinking about this the following way. If you have different users, developers, infra and ops, maybe security, maybe executives, all of them should have an ambassador. And the ambassador of the developers is the DevX platform engineer, thinking about, how do I optimize, you guessed it, the developer experience. The infrastructure and operation people send their infrastructure platform engineers as ambassadors. Those are responsible for standardization, for reuse of modules, for shaping golden paths, and all of this. But, very important, all of those personas serve a common goal, and that is, you don't serve the managers, they are just facilitators. You serve the organization, everybody around you, because your job is to bring time to market and cost down and innovation up. And if you are not able to do this, then you will not have a seat at the table in 12 months from now. So I'm always asking, if people come to me with an initiative, okay, can you explain me on a napkin how you're going to save the organization money and have an influence on top line or bottom line? And if they cannot give me an answer like this, and all they're saying is, yeah, we lead to more visibility, that's really cute, but you're not going to survive. Okay, so what do I mean by a high degree of automation and standardization? How do you structure that in a way that leads to a high return on investment? And to answer that, I want to look at what, in my opinion, is not a high degree of, and we will start with automation. And I'll use the example of a developer who wants to add a resource, in this case a Redis, to an existing workload. Now, this is an important question here. If you're evaluating stuff, I encourage you to use this as the example. How easy is it for a developer to add a Redis to my, really important detail, existing workload? Because most platform engineers go out and they say, we want to make it very simple to scaffold a workload. Okay, cool. But I mean, how often do you scaffold a workload? Yeah, we're a large company. We have 500 developers. We scaffold 40 times a year. Okay, 40 times a year. 40 times a year is not much. How much time do you save if you're scaffolding a workload? Plus, scaffolding a workload is easy because you don't have a prior dependency. Scaffolding something is relatively straightforward. You can use the GitHub template API. You clone something, you let GitHub Actions run, and boom, you have something scaffolded. You don't need rocket science. Why don't you need rocket science? Because there is no existing brownfield dependency. The complexity comes in if you have something, you're a developer, you've been developing that workload for a while, and then somebody comes around the corner and says, like, we need Redis for that workload. Okay, so what do? In a low automation setup, you go ahead. Let's say you have a template for how Redis should look. All right, you take that template, you let it run, it gets created, and then you adopt your application configurations. You check the policies, you run a sign off, you reference the secrets. You do that for all the different environments. That for me is a low level of automation. You might as well do that manually. And you need to find developers that are capable of doing all of that. Now, sure, some are, but many aren't, or many think they are and aren't really, and they're going to make quite a mess. Now, for me, a high degree of automation is The user expresses their intent. I need Redis for my workload. Business logic kicks in, bam, done. The second bit here is standardization. If I'm looking at most setups exclusively built with Backstage. Then they have this scaffolding button, boom, 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 you scaffold, that creates new repositories. The second that thing is scaffolded, it's standardized because it's following your global template. But from here to all eternity, over the entire lifecycle of that application, that configuration is going to drift. And you're going to end up with 200 different ways of configuring Postgres databases in staging. Now, there are not 200 ways of configuring Postgres databases in staging. That's not something that exists. There are maybe 4 or 5 ways. And even though something like RDS has 195 parameters you can tune, in reality, nobody does that. And it leads to a wild degree of maintenance because somebody will have to maintain and update and secure all of those resources. Think back of that infrastructure Tetris. So a high degree of automation for me means all my Postgres databases in a specific context, in this case, an environment of type staging, all look exactly the same. That's what we mean by a high degree of standardization. And that's why your platform needs to follow and actually manage the life cycle of that resource. And now just looking at this here, that's not something that a front end will get you, because a front end is a front end is a front end. It is meant to display stuff. It is not meant to actually execute complex business logic. So there are backends, there are front ends. I would always argue, but there is a bias in me, although, I am heading an organization that offers front ends and back ends. So, I think I'm fine. So anyhow, I think the actual juice and the return on investment is in the logic layer and not in the front end layer. Honestly, my personal opinion, front ends are built to showcase stuff to managers so it looks fancy. They're not really used. Or if they're used, it's 5%, and the rest of the organization is used 95%. And so I understand that we need to please managers, absolutely, but we need to make sure that we look for return on investment, because yes, great to get through the first showcase to your executive team, but again, in the end, they just care about return on investment. Yeah, so if you've been following me in any way, you know that I'm very, that I'm of the opinion that platform architecture is like software architecture, and that the same principles apply. You have a front end, you have a back end, you have logic handling components. You need to, keep developing this architecture. The state should be stored in code. And so this here is the most standard, reference architecture, and frankly the most rolled out platform that I'm currently working on. So we have a mantra at Humanitec that managers have to do at least 4 platforms, or have to build at least 4 platforms with customers at any given point in time. So I'm spending around 30-40% of my day actually building platforms. We do this to avoid that we only talk bullshit. And so if you ask me, like, what's the platform that I build most with customers, it probably looks like this on Amazon, really. Like, you have a front end with portal. Honestly, 60% of the portals are Backstage, right? And that's fine. I respect that if you do that for the right reasons. And then you have a version control system with, Score as a code-based interaction method for developers. We've donated this to the CNCF, so I don't think even it's advertisement if I speak about this. But this is sort of a fantastic thing to help developers articulate things in code. You want to keep developers in the inner loop. Developers do not like that thing the Netflix guys had with, hey, it wasn't attractive enough to pull developers out of their existing habits and routines. It's wrong. You do not want to pull developers out of their existing habits and routines. You want to leave them where they are, because change is expensive, right? You want to keep them in the inner loop. And so that means you want to optimize for CLI or code-based interactions. Anyhow, so that's here. Then you have the back end, you have CI, you keep your existing CI registry, you have an orchestrator. And an orchestrator is essentially a logic handling backend. We are going to speak about backends. You essentially have two options, but I'm a big fan of an orchestrator, a graph-based backend. And there are more orchestrators than Humanitec, right? And you should go out and also investigate that to make sure that, I really believe we're getting into the era of orchestrators. And you should look at Microsoft Radius, for example. You should look at Syntactocratics, for example. Those are, open source products worth looking at as well. And what combines them is that this idea of orchestration and that idea of graph-based approaches. Okay. Then you sync this, and then you have your resource plane on whatever cloud and whatever on-prem infrastructure. You weave this up with monitoring and logging. You weave this up with security planes, policy checking, secrets management, whatever. Now, if you're designing backends, you have exactly two options. The, in parentheses, historic option is I'll abuse my CI pipeline. CI pipelines are great. I've been doing this for years. CI pipelines are good for platform orchestration. Not really, but you can, that's the most tried approach. So you can essentially do this with, or try to do this and mimic the behavior with GitHub Actions and Argo CD and Terraform and Crossplane and whatnot. That is an idea that works. It scales to a maximum of 200 developers, because afterwards, what happens is pipelines are linear. Pipelines have start-stop logic. Pipelines need an incredible amount of code to represent the same amount of entropy that you would have in a graph-based system. And that, this sounds like a lot, and you'll need a while until you're in that state of graph-based backends, but that is a huge difference. And I really encourage you to check out those graph-based options as well, because they do a lot of good stuff. Yeah. The pros of the CI-based approaches, again, you have that already in. You can use GitHub Actions or Argo. You have all used CI pipelines. The problem is that anything that goes beyond environment progression is pretty difficult. It's pretty difficult to do that second day operation well. It's pretty difficult to do fleet operations. And so I am not a big fan of this. Yeah. So graph-based platforms, the idea is that you have developers on the one hand writing workload specification and essentially expressing intents. And then you have another group, or this could be the same developers expressing, resource definitions. So how does is a resource supposed to be configured in a given environment? The orchestrator analyzes this plus the context and generates app and infrastructure configurations. Now, that's actually what I want to explore a little bit here. Also, my recommendation, what you should do is you should think of a data model in your platform, and you think about what's my abstraction logic if it comes to the relationship between workload and resources. And we have built this here, integrated this to the CNCF, and now there are more contributors. It's essentially like a code-based format that you can scaffold from your backstage. Maybe I'll have enough time to quickly show you. And you essentially say, hey, I have a product service. It needs a Postgres, S3, DNS, and route, right? And that's the same file for your local dev staging production environment. It sits next to your workload source code, and it can replace all other app and infrastructure configurations. And then you have, on the other hand, your global conventions, if you want. Golden paths, we call them resource definitions. And you say, hey, if my developer needs a Redis and I'm deploying to staging, then I want to use this parameterized Terraform file to update and create that resource. And if you then bring this together, you have your conventions. Those conventions, by the way, can also, if you are on a you build it, you run it schema, you can also let your developers write those conventions. No problem. That's a question on how you set role-based access control. And then the user is sending that abstract request, flies through the CI pipeline, the orchestration analyzes the context and goes, okay, for staging and Postgres, those are the definitions we're going to use. we want to have sidecar containers for Datadog, and we want to have labels and annotations and whatnot, and then generates an acyclic resource graph, one for every environment and one for every deployment. And that means if we now get back to that example of I need a Redis, that means I need 2 lines of code, give me a cache of type Redis, flies through the CI pipeline. The orchestrator analyzes this and generates the Redis for you. And if your team says, hey, by the way, we're updating how Redis is done, then developers can literally put infrastructure on autopilot. And the next time we are changing the definition of Redis, all graphs that consume this will auto-update for us. So really, the orchestration is now taking over the lifecycle management of that respective periphery resource. And that is a huge difference because it avoids us having to now actually maintain all of that. This gives you this graph-based approach. So now you don't have now you have this huge range of different infrastructure repositories and stuff happening here and here and here and here and here. That's gone. You have a graph-based view. You can query that graph. You can put a fancy LLM on top, throw it against the ChatGPT API, see what happens. Like you could do all sorts of fancy things. The logic is you have an org level, app level, environment level, service level, and resource level. And then you can say, okay, let's put role-based access control on top of the graph. So now some developers are able to change things in lower level environments, but we are back the changes to production infrastructure. Now we can say, hey, give me all resources of type Redis that are using the same resource definition, so that are on the same standard in orange. I can say, show me everything where my orchestrator already lifecycle manages everything in red. Endless possibilities. And that means if you have a well-established backend, and that is my key message today, then you can put whatever on top. You can let people consume this through a Twilio API and send them an SMS. I don't care. You can put Backstage on top. You can put Cortex on top. You can put Port on top. You can put Ops level on top or ServiceNow. It doesn't matter because there is a backend API. There is a graph. There is a high degree of automation. There is a high degree of standardization. And so, yes, you can absolutely, in that case, also put Backstage on top and all is good. And that combination gives you the golden paths. And that's important. Golden paths, not only for developers, but also for infrastructure and operations people and security people. And that means infrastructure vending machine, here you go. Ephemeral environments, no problem, because everything is generated all the time. Global update of infrastructure and fleet management, diffs, security, scaffolding, all of that is absolutely possible through this approach. Yeah. And that's the approach that I want to show you right now. I have to connect my useless Apple mouse to my computer quickly. That worked because it charged. And you all now know how great this design is. Okay, let's have a look. Where's my terminal? Here. Terminal. I called my terminal and nothing happened. Here we go. Okay, so this is my terminal. We have a little set of scripts that allows platform engineers to sneak into all parts of their reference architecture. You just do OBRR, Open Backstage Reference Architecture, and then Backstage magically appears. Just for orientation, I'm going to demo this setup. So we're going to use Backstage as the portal. We have orchestration in the background. We are using Score for the workload specification, and everything is running on Amazon. I could demo this on Google or on Azure or on OpenShift or on multi-cloud or on Moonrover. But for this demo, we're going to choose Amazon Web Services because, and the other clouds don't like to hear this, but this is the most commonly used one. Cool. So here is Backstage in all its glory. We have all my components here in my catalog. We have a create button that brings us to scaffolding. So let's say I'm a developer. and I want to create a new service today. I woke up in the morning and thought, this is a good day to create a new microservice. And boom, I'm hitting the create button, very convenient. And I get my different options for scaffolding that you've prepared. One to do Node.js, one for C#, one for .NET. And today we're going to just use this pod info service template. We select this, and then we always give it beer brand names, but I forgot, because I'm German, I have to use beer brands. But I have already used so many beer brands, I'm running out of beer brands. Yeah, it doesn't matter. And okay, so then we hit review and we create and we can look at the logs. So what does Backstage now do? Backstage is a JavaScript, front end that essentially it takes a couple parameters. It calls the GitHub templating API, and it then clones or scaffolds that repository, and then it starts GitHub Actions. That's all it does. Once this is done, it's taking that, because there's a Backstage YAML file, and registering that back into the service catalog. That's all the magic. There's a lot of buzz about very limited functionality. Okay, so this is done now. We can look at the repository. And I want to show you quickly what we scaffolded is the application source code repository. So this does not contain any app and infrastructure configurations. It contains the workload source code, and it contains a score file. Okay, workload source code. Okay, cool. And the score file. So we have here a score file called Lübzer beer. Very good beer. Should you ever be to Northern Germany, because I don't think they have it in Southern Germany, but in Northern Germany, Lübzer is a very good beer. And we see that we have a service called Lübzer beer, and that we depend on a DNS of type DNS and a route of type route, and that is pretty much it. A very, very trivial service. Cool. And now we can have a look at Backstage and go into the catalog. And you can see that this is orchestrated by the orchestrator. And the orchestrator has created the development environment. And we have a workload called Lübzer beer. And we have a DNS. And we have route. And everything was created for us. And we could go into, we can look at the URL and ping. And we have a TLS certificate and everything. Cool. Actually, one thing that we want to do soon is that we want to add, because that is a Backstage plugin for Humanitec, but we have a way of displaying the resource graph, which I will show you. Quick sneak peek, which we are not pushing to Backstage yet, but this is coming. So here, the resource graph gives you like a visual representation of all of these things that Humanitec created fit together. So you have a workload, you have a route, you have a DNS, TLS certificate, logging setup, base environment, ingress, and all of that. Good. Now, let's do something that's a little more complex, and let's assume we are a developer, and let's actually do that Lackmus test. I recently learned that you can also say that in English. And we are going to add a resource to an existing workload. How do I do this? Well, I could just click in Backstage, add a Redis, but I am going to do this through code, because 95% of the people that have a Backstage set up with Score are using Score in reality. And that data is pretty recent data. Okay, so how do I do this? How do I add a Redis cache? Now, obviously, I wouldn't do that in the version control system. You would do this in Visual Studio Code. And in Visual Studio Code, we have all sorts of fancy things where you can already ping the API while you're writing, and then it will say like, hey, no, Redis wasn't configured for your organization, and it can catch errors before they occur. And like, I'm going to demo this in the version control. Why? Because all of you have their own idea of how a good IDE setup looks like, and you're all terribly opinionated, so am I. So it's easier if I just show you that in the visual in GitHub, so you can then explore for yourself how that fits into your IDE. All right, so it's read only. That's sad. Let's change this. So here we go ahead and we say, give me cache of type Redis. I could also say, give me a DB of type Postgres. I can say whatever is configured, but I'm just going to give you a cache of type Redis. All right. When I'm done, I hit commit and I have a bad day because unfortunately, my other colleagues in the engineering team are currently testing on the development environment. So I will need to create a new branch, propose change, but surprise, no problem. I can create the pull request and now the CI pipeline will run. And it will now push this to the orchestration and it will say, I mean, this is kicking in a second, and it will say, hey, here we go. We please want a PR environment. Because this orchestrator is generating the app and infrastructure configurations anyways every time, I can absolutely just take that app.score file, send it against the orchestration and say, give me a new PR environment. And so that's exactly what it's doing at the moment. It will actually create that PR for me. And it will analyze the score file. And it will realize that, oh, there is a diff. I need a Redis for that PR environment. It will then analyze how am I supposed to create the Redis. And for that, it will actually look at the resource definitions again. The resource definitions are stored as code. Let me show you a resource definition for Redis. Here it says if infrastructure type equals Redis and we are deploying to production, which we're currently not, so that example, then use this parameterized Terraform file to update and create the resource. If we look at that Terraform file, which is here, you can see that it is an absolutely normal Terraform file. So nothing special here. And so with that information, the orchestration will take this, it will create the Redis, it will then ping the AWS API, it will inject the credentials at runtime into the container, it will serve everything, and it will do this for all the resources that you requested. And obviously, we have a very simple example here. You could do this with applications with 50 microservices and 150 resources, and that works just as fine. Okay, so now while I've been bombarding you with banter, the GitHub Actions job has been running and it has created everything for us. If we go back here, we see that Humanitec has that now deployed. We have a PR1 environment and we have a new thing that we can test with, like a new URL. And you can see that we're streaming all the information like deployment, diff, resource graph right into the CI. We can, of course, look at this in Backstage now. So in Backstage, we see we have a development environment, we have a PR environment. You can see that there's now an external cache that I can look at. I can understand why was this cache created. I see the relations, I can see tech docs. But again, our design logic, if we are designing platforms, honestly, my philosophy is always try to keep the user as close to the inner loop as possible. So my mantra is always, if possible, let's give them the information in the IDE. Let's stream that somewhere so they can consume this wherever they want. If that's not possible, okay, well then can we maybe display that in the CI like we're doing this here? Can we just maybe keep them in GitLab or in GitHub Actions? Like I have like no interest in them even knowing that there are other systems under the hood. Like why? Like what do I win from that? If that doesn't work, I will say, okay, well then let's actually surface that in the user interface. Yeah, so that's what we did in this example. So again, it doesn't matter. We can surface this here or there. All right, and now we've been developing this for a while. Life is good. And then I merge my pull request, confirm merge. And again, CI pipeline is running and going, okay, we don't need this anymore. We can fold this into the main branch. And this is now literally calling the orchestration again and going, hey, orchestration, we don't need the PR environment anymore. Can you please delete this? Can you get rid of it? This is expensive. Because a lot of organizations are really afraid of PR environments because they can drive the cloud costs. And you know what? They're absolutely right, because they can drive the cloud costs if people have like 400 different PR environments running around. That's not going to happen with the orchestration, because the orchestration is actually screening whether there's load on those things, and it's going to proactively tear them down if this is merged. So in a couple of seconds, you can already see this the PR one, it has been auto-deleted by the orchestration. But you can even go further. The orchestration can do things like put things to sleep when the developers aren't working, or pause environments on schedule, surface idle environments, and all of these things. Yeah, so we are now at exactly 45 minutes, and I think we've reserved 15 minutes for questions, and I am going to stop sharing and see whether there are any questions.
Yes, Kaspar, here we have one. Thank you for your valuable information that you shared today with all of us. Here, Ari is asking, did the tool use the YAML definition and create Terraform resources from it and deploy them? Do I understand that workflow right, or I am missing steps in the middle?
That's a fantastic question. Yeah, absolutely. Yeah, you got that right. So it's taking the YAML definition. The YAML definition, so Score, is an open source standard. So in itself, it's there needs to be a translator function. So you have the Score. Score gets translated with an implementation called Score Humanitec into JSON. So the orchestrator can, because the orchestrator is an API, so the orchestrator can interpret this. And then once this is in, the orchestrator is going to look at the context and going, okay, they need Redis, they need Postgres, they need bam. Let me find out what the right infrastructure as code, or this doesn't mean like Terraform. Yeah, I mean, if you're in the Terraform world, it will take Terraform, it will update this. Once this is created, it was going to ping the cloud API or on-prem, pull the credentials, inject them through secrets, wire everything up and serve. You could also have a situation, first of all, you can have a situation where you want GitOps mode. So then the orchestrator is just spitting stuff out into a repository, and you pull that in with Argo, which can make a ton of sense because you want to have code in, code out GitOps workflows, and you want to have policy checking and a different stand on security. But there are a lot of situations where you want to use other infrastructure as code. Crossplane is getting more and more popular. CloudFormation, Pulumi, and often if we are working at enterprise scale, you have a situation where one team is on Terraform, the next team is experimenting with Crossplane, you have Pulumi, and you have one team that doesn't want to use infrastructure as code. Now, you need a concept that can deal with all of them. In the end, you have a thing that's called a driver. And the driver is essentially, you can have a Terraform or like a general infrastructure as code driver who's executing the infrastructure as code. Or you can have a driver that calls the cloud API directly and says, okay, Amazon, I want you to do ABC. Let me give you an example. If you want to do, if you need a certain sidecar proxy, for instance, that's hard to impossible with Terraform. So then you need to tweak this. You need to also inject this into the workload configurations. And so this system is pretty much able to deal with whatever you, or not whatever, but many things you throw at it. I hope that made sense.
Yes, totally. Thanks, Kaspar. Here we have another one from Bjorn. It says, I have a management question to the intro regarding Roy for building a platform team. What is the sequence of you would suggest building a platform backend?
For the return on investment for building a platform team, which is okay. Good. So that's actually a great question. Now, my recommendation is, and I've been sharing this in other webinars, and maybe we can send that over, or we will do another one. So this is sort of how to avoid the biggest failures in your platform engineering initiative. And I think they're covering it also during the platform engineering certifications. My recommendation, if you're building this, is to start very small and very, very slowly. So I'm a big advocate on taking things slow in the platform world. Now, because management is coming out of a situation where for years we've been promising them new things. We've been promising them DevOps. We've been promising them you build it, you run it. We've been promising them like every time there's a new vendor coming around the corner and saying like, hey, this time it's different. And so they are a little allergic to this. So my recommendation is to say, don't ask for anything. Prove yourself first. And start very small. You don't need a standing platform engineering team for the first phase. You take one or two guys from infra, you take a person from the app devs, you involve a security person, and you sit them down and say, okay, can we maybe build an MVP, a minimum viable platform, in like 4 to 8 weeks? And then you do this by focusing, and this is sort of there's a lot of theory about this, and I'm condensing this into like a 3 minutes answer. So you need to dive deeper, but like, you need to research on MVPs, and then you want to build something very fast, and you want to build that optimized for one team that is on what I call the lowest common tech denominator. So that means, what's the team that's representing your future tech stack? That could be containerized on EKS. I don't know your setup, or it could be OpenShift, or whatever. You then spend 4 to 8 weeks of that team, that small team that you've assembled, and you let them work on this 25% on their time, and you let them build that minimum viable platform. That will cost you not that much, and you build something that's great only for that one team. I always say that platform engineering is a lot like building a startup. And there is a famous article by Paul Graham that at the start of a startup, you should do small things that don't scale. Same holds true for platform engineering. Don't think about scale. Forget that. Focus on that one team. Make that life for that one team amazing. And essentially, by doing this, build your future operating model. So then once you have that one team, actually look at, do they like this? Iterate with them. Take this to production readiness. Takes another 4 to 8 weeks. And once this one team is using this every single day, and they go, hey, this is amazing, and they tell their friends, then you go to your managers and say like, hey guys, we've built something amazing. Like, look at the return on investment. We've measured the workflow performance before. And there's sort of a set of measurements that you can use. We are measuring the workflow performance with the on the new platform, even though after 16 weeks it will be only like a tiny platform. This will make a big difference if we think about a platform like a product. You see the numbers here in the return on investment calculation. Are you okay with me taking this now to 10 teams? And that's how you do this.
Thanks, Kaspar. Here we have another one from Guillermo that says, what other alternatives are for Score? And I guess any other alternatives for the Humanitec orchestrator?
I think I already mentioned a few, but let me mention them again. So for Score, you could look at the OAM, Open Application Model. That's something. You can look at ACORN, that's ACORN. All of those three are open source. And definitely something to consider. For the orchestration, you might want to look at Microsoft Radius. That's RADIUS, CNCF project donated by the Microsoft team. That's worth looking at. And then there is Syntasso Kratix. That is KRATIX. And all of those tools are doing things well and definitely worth checking out.
Amazing. And here we have the last one from Terry that says, to beat the case for a platform orchestrator showing the current state of a resource graph, especially if lack of standardization and automation would be useful. How would you recommend representing the current state of the impact and the organization's efficiency?
Good question, Terry. Actually, the same way. You need to build a lean setup so that we are able to extrapolate from this. Because I do not believe in, maybe you have a, so look, let's put it like this. If you have a strong manager who's very technical, then you can convince them with technical arguments. Unfortunately, managers are either strong or technical, and very often they're neither strong nor technical. So you usually have a problem. And so that means you need to create realities, and then you need to build a return on investment calculation, and you need to show them this way. And you need to be able to say, look, currently we're spending this much time updating Postgres databases from version 14 to 15. This is how it is afterwards. Look, now I can give you an interface or a chat GPT that allows you to say, can you list me all of my Postgres databases in staging? Managers are very often caught by providing visibility because IT is so intangible for them. They can't see anything, they can't feed anything, it doesn't look fancy, there's nothing to hold on. That's why they're all looking at engineering efficiency KPIs, although I'm never really sure what you want to do with them. But they always see the costs increasing, and they see the features not making it to production. And so they go crazy. So if you're just saying like, hey, we have a graph, we can visualize anything, and I can say, these nodes are already on the new operating model. These are the ones that are currently cleaning up. That could be helpful.
Perfect, super clear everything. And we have two more that if you can, we can do it quickly.
Yeah,
one from Kevin
sure.
that says, in your demo, we saw deployments to PR environments and presumably a deployment towards the development environment. How would a system like this deal with promotion of deployments to other environments, standing, prod, and so on?
Mm-hmm. So first of all, the same way, you have the abstract definition, which is the same across all environments. You just change the tag in the version control, and then you're deploying to staging. And in that case, you would be using staging infrastructure, right? In the development environment, that the example that I showed, I used in-cluster resources because it's cheaper. And then you swap that in the development, you would use Elastic Cache for Redis in the Amazon case here. You are asking an important question because as you are promoting towards production, you want to add additional guardrails, right? You want to maybe have policy checks. You maybe want to have manual human sign-off. Security teams want to look at this. And so some orchestrators have a built-in deployment management and automation functionality, which will help you do the inter-environment progression. If they don't have that, you can try to script that in the CI pipeline. But then you need to actually manage that pattern. Before we go, I want to answer one more question here from Adam. You've made a couple of references to GPT front ends. Are there particular areas and problems you're excited about AI being used for? That's an interesting question. You know, the problem with, or in parentheses, the problem with infrastructure is that, you know, we have a little bit of a, I would call that a self-driving car problem. Elon Musk is going on stage every 6 months when the stock market isn't performing well, and says, we are going to have self-driving cars soon. I get why he's doing this. I would do the same. But we still don't have self-driving cars. Why? Because if you have a self-driving car, it's not okay if you're 98% of the time right. The same thing holds true for infrastructure. It's not okay if we're 98% of the time right. And in between, we don't really understand what the LLM did. That means GPT or AI cases at scale in close to production, we're still far away from that. I'm not saying that's not coming, but that will be a while. Because let's assume you have an estate with 200 databases right now, RDS, and I'm coming and say like, hey, I can standardize them all with ChatGPT. Now, I would need to assume ChatGPT knows how the application performance is, how we want the application performance to be, whether the source code is prepared for that standardized setup and all of that. So that's why the actual area of optimizing infrastructure, we're still a little far away, I think. I have not seen many cases where I would say, that looks like something that we can really put into a core banking application. That said, there are things where we can make use of this. An example would be if you have a graph-based system, for instance, like asking that thing questions and making correlations and saying, are there any patterns we're observing? And using that to retrieve information. I don't think you get more or less value than out of a front end. The beauty with these GPT front ends, so to speak, is that you don't need to maintain them. Like Backstage, or less. Backstage costs you, depending on your size, something between, I would say like 2 full-time equivalents, more or less, 1 to 2. That means you're looking at 200, 300 for larger organizations, 450,000 for fully loaded for running these front ends. You can do a lot of requests to ChatGPT, right? For that money, and you probably have less headache and overhead. So if you have a good backend, if you have the metadata, why not just use an LLM to ask questions? I find that pretty appealing.
Amazing, amazing. Kaspar, thank you very much for your time. Thanks everyone for joining us today. It was an amazing webinar for us. Please remember that if you are not in the Slack channel, you can join us and also ask Kaspar questions, or everyone in the community. It's very helpful for everyone. And I think that this is it for today. I don't know, Kaspar, if you want to say something, but this is the end.
We're launching the new Platform Con. And I want to advertise for the live days. We are going to have now, for the first time, physical events. They are going to happen in New York. They're going to happen in London. So one for the States and one for Europe. For now, so sorry to our Asian and African friends. I hope we do that in 26. But great spirit there. I was at the live day in London where we did it at a smaller scale. We'll do it much, much larger this year. I'll try to be at both. I'll try to be at the one in London and then fly over to New York. So I'd love to see you there and deepen the conversation. Thank you very much for your interest, and talk to you very soon.